All right, everybody, so part 2 of our video here is going to deal with what happens when our center is not at the origin. Well, I guess a little bit more in depth for us, but honestly, just like before, all of the calculations are identical. We just have a slight change to some of our formulas. So standard form, instead of just x squared, it's now x minus h squared. Instead of just y, it's y minus k squared, so nothing new there. Still minus h and minus k, which means that we're going to be taking the opposite signs of those. So whatever number is next to x, take the opposite sign. Whatever number is next to y, take the opposite sign to get your center. Let's see, other things that we need to know. So the other form of this would be y minus k squared over a squared minus x minus h squared over b squared equals 1. So again, this is when our transverse axis is on our y-axis. And this one here is when our transverse is on the x-axis. So again, basically the same equations from above. We just have to add in the h next to the x and the k next to the y. Other things that basically change here are the equations of the asymptotes. So for the asymptotes, when our transverse is on the x-axis, we have y equals b over a x minus h plus k, and we have y negative b over a x minus h, and then plus k again. So those are the two. For over here, slight change, y equals a over b, still x minus h and still plus k, and then just the negative form of that same thing, negative a over b, x minus h plus k. So this basically accounts for the shift. So if we move left, right, up, down, this is representing our left, right. This is representing our up, down motion. And if the center shifts, everything shifts along with it. So same thing with the vertex, with the focus, and with the equations for the asymptote as well. So let's try an example of an equation like this, and basically how would we go about calculating with our new not origin-centered hyperbolas. So if we have a center at 4, 8, we have a focus at 4, negative 2, and we have a vertex at 4, 10. So center is 4, 8. We have a focus at 4, 2. That's quite far away. And we have a vertex at 4, 10. So the distance from the center to the vertex here is we have to go from 8 to 9 to 10. So that's going to put our A value at 2 jumps. And then our distance from our center to our focus here, quite a few more jumps. We have to go 8 down to get to the x-axis and then 2 more below. So it looks like we have a jump of 10 in this case. So quite a bit of distance to get to that focus. Okay, so just like before, identify all the things that we need to. So A equals 2. We don't know what B equals. C equals 10. We can use the equations that we were using previously to go through and solve here. So B squared equals C squared minus A squared. Or B squared equals 100 minus 4. In this case, B squared equals 96, and just B by itself is going to be the root of 96. In this case, take that root, it's going to be a little bit less than 10, like 9.8, with some rounding there. Okay, so now that we have this, a few things that we should note first is that this is a hyperbola that's going to be going up and down. So our transverse axis is now the y-axis instead of the x-axis. So a different equation to use. So we have y minus k squared over a squared minus x minus h squared over b squared equals 1. So we can start off with our center of h comma k. So y minus k squared minus x minus h squared equals 1 over, we know that a squared is 4, and we solve that b squared equals 96. So that's one important equation, the equation of graphing the hyperbola. We also need to know our asymptotes. So there are two. So we're going to have y equals a over b x minus h plus k. And we're additionally going to have y equals minus a over b x minus h plus k. So y equals 2 over 9.8 x minus 4 plus 8. Again, plugging in a, b, h, and k. We'll do that again. Y equals minus 2 over 9.8 x minus 4 plus 8. There is our second equation. All right, so that's the idea. A bit of a shift, honestly. Everything else is the same when our center is not at the origin. So just be careful plugging into those formulas. As long as you do that,